Okay, this next video is going to show you the difference between growth and decay. I'm just going to do it by, I'm going to show you how the curve looks on Desmos. Now, in the previous video on the basics, it showed you that growth is when the multiplier is anything greater than 1. And decay or decreasing is when the multiplier is anything less than 1. Doesn't matter what the y-intercept is, what the a value is. Remember, it's y equals ab to the x. The a value is just the starting value. It has nothing to do with growth or decay. So if you were looking at a word problem, you could say the population of a city is 100,000 people and is growing at 10% per year. Okay, so that starting value, 100,000, that's your a value. We said it's growing at 10% per year, okay? So you could do something like that. You can say I buy a car for $20,000 and it depreciates, which means it goes down in value by, say, 5% a year. At $20,000 is my starting value. So it doesn't matter whether it's growing or decaying, that's just the starting value. Okay, but I'm just going to use simple numbers here. So I'm showing you growth. When I said the multiplier is greater than 1, let's pick a big number, okay? So I'm going to use the same y-intercept, the same starting value for a for each one of these, just so you can see they all go to the same point. I'm going to use the starting value of 2. 2 times 100 to the x power. Now, you can see how it increases very sharply because 2 is the first value at 0. When y equals 1, x is equal to 100. And then when y equals 2, x is equal to, it's going to be 100 times 100. Or actually, the value is going to be 200. So it's 2 times 100. So it's going to be 200 for the x equals 1. So it's going to go up very, very sharply, very quickly. Okay, that's if you have a high growth rate, a big multiplier there. So let's just pick another number here. Y is equal to 2 times, remember I said I'm going to use the same y-intercept, 2 times 10 to the x. Okay, so now the first value, when x equals 0, y equals 2, so you multiply it by 10. So the first value would be for x equals 1 would be y equals 20. And you can see right here when x equals 1, y is equal to 20, but it still is growing pretty sharply. Okay, let's do another one. Y is equal to 2 times 5 to the x. Okay, now when x equals 1, y equals 2 times 5 is equal to 10. So it goes right there. Okay, so you can see where we're going on this. Y is equal to 2 times 2 to the x. Okay, so it's growing less sharply, but still it's doubling every time. It goes 2, 4, 8, 16, and so forth. Okay, y is equal to 2 times 1.5 to the x. Okay, you can see where we're going there. Y is equal to 2 times 1.2 to the x. Y is equal to 2 times 1.1 to the x. So you can see as I get closer to 1, it's getting shallower and shallower, but it's still growing. I can pick some really, really small number above 1. Y is equal to 2 times 1.0001 to the x. Okay, Now, it almost looks like a straight line. Okay, see that? Almost looks like a straight line. So if I zoom way out, and it still almost looks straight. Okay, eventually it'll start curving up, and it's hard to see. There it goes. Starts curving up, but we're looking at it x equal 50,000 or x equal 100,000 when you get a number this small, but it's still growth. That's my point. It is still exponential growth. Let's get that one out of here. It's too hard to look at. But my point is that this, on the scale, look at all these others. They're so scaled so small that it almost makes them look like they're all the same thing. So y is equal to 2 times 1 point, just go 0, 1 to the x. Okay, and you can see the black line here. So it starts curving up faster than that previous one, but definitely shallower than all these over here. Okay, but it's still growth. If I said 2 times 1 to the x, 1 to any power is 1, so it would be a straight line. Okay, it would just be y is equal to 2. It would be a straight line at the y-intercept. Y is equal to 2. So that's why a multiplier of 1 makes no sense, because every time you multiply by 1, you just get the same number. And that's really a graphical explanation of exponential growth. Anything greater than, any multiplier greater than 1. And it doesn't matter what the a value is, the y-intercept. That's just where it goes through. You can see all these curves go right through that same point right there at y equals 2. X equals 0, y equals 2. Okay, because that's the y-intercept. That's all that's saying. If I did the same thing for exponential decay, then basically it does the same thing. If I put in 1 divided by 100, let's eliminate all this stuff here. See, and I probably have to put this in parentheses because I want to make the whole thing an exponent. So to the x power. Oops. To the x power. Okay. Now, see, the y-intercept is 2. So here's this blue line coming down. It goes through 2, and now it's getting small very quickly, very quickly. And if I change this one here to 1 over 1.01, put the parentheses right here. Get rid of this. Get rid of that. Okay. I think that's a multiplier. Okay. To the x power. Okay, so it goes through there, but you can see now it's still exponential growth, I mean decay, but you can see I have to scroll way out. You can see it's coming down, coming down, coming down, comes across here at y equals 2, the y-intercept, and then keeps getting smaller. So the closer your growth rate or decay rate is to 1, the shallower it is. The further away from 1, in other words, the bigger number it gets, or the further away it gets, the closer it gets to 0, or it can't go to less than 0. It can't go to 0 even. The less it, the further it gets away from one on the small side, the shallower it gets, or the steeper it gets rather. Like this blue line here was 1/100, which is 0.01. Okay, so that's just to show you graphically how growth and decay work on a graph. And I hope this helps.